Okay, working exam 1 review solutions here. First one, we're going to multiply this out. So we're going to multiply here to here first. That'll give us 2x cubed. Then we'll go 2x times negative 3x, gives us negative 6x squared. And then 2x times negative 5 gives us negative 10x. Then we move to the second term here. Minus 3 times x squared is negative 3x squared. And then minus 3 times minus 3x gives us plus 9x. And then minus 3 or negative 3 times negative 5 gives us positive 15. And now we just collect like terms. So let's see, we only have one x cubed term here. So it becomes 2x cubed. So that takes care of that. X squareds, I've got those two. I can put those together. That's negative 9x squared. And then these two I can put together. That's going to give me minus 1x. And then that leaves me with the 15. So plus 15. There we go. So we've multiplied that out. Okay, the next one is 3x minus 2 cubed. Pay attention to that cubed. So what that means is 3x minus 2 times another 3x minus 2 times another 3x minus 2. So I always like to do the second group here first. So I'm going to FOIL those out. So this times this. Let me put the 3x minus 2 up front. So multiply 3x times 3x, get 9x squared. 3x times negative 2 gives me negative 6x. And then again, another negative 6x, and then a plus 4 at the end. And now let me collect like terms on that one. So I've got 9x squared minus 12x plus 4. And now I'm going to do the same thing I did before. I'm going to multiply the 3x through to everything. So 3x times 9x squared gives us 27x cubed. 3x times negative 12x gives me negative 36x squared. 3x times positive 4 gives us plus 12x. Okay, now I'm going to move to the negative 2 there and multiply through. We get negative 18x squared. And negative 2 times negative 12x gives me plus 24x. And finally, negative 2 times positive 4 gives me negative 8. Collecting like terms together, I'll have just the 27x cubed, takes care of that. Let's see, x squareds, I've got those two, so that's going to be negative, let's see, negative 46, negative 54, x squared. Then we get the 12x and the 24x, add those together, we should get 36x. And then finally, minus 8. So that's that. Okay, on this next one, I'm going to try and squeeze all this in here. This is the answer to number 2. So for number 3, we're going to reduce this. So first thing I'm going to notice is that the x squared minus 16, that's the same as, that's a difference of squares. So it's x plus 4, x minus 4. And then if I have a fraction divided by another fraction, I can turn it into multiplication of the reciprocal. So I can bring the bottom fraction up, flip it, and basically take the top fraction and multiply it by its reciprocal. So I have a 3x on the bottom here. So that's no longer here. And then let me see, can I cancel anything out? I can cancel the x plus 4 out. And that just leaves me on top the 4 minus x times the x minus 4. Then on the bottom, let's see, the only thing left on the bottom is 3x. And that would be fine. We can just leave it like this. Okay, same thing on this one. We want to divide and simplify. So for this one, really the main idea here, let me see if I can squeeze a little more room in here. The main idea here is to do some factoring. So let's try and factor all this out first. This will be equal to, okay, this factors, let's see, two numbers that multiply to be 54 and add up to be 15 are 9 and 6. So that factors to be x plus 9 is x plus 6. On the bottom, two numbers that multiply to be 54 but add up to be negative 15 would be minus 9 and minus 6. And then all of that is over. Okay, two numbers that multiply to be negative 54 add up to be 3. So let me see here. Let's see, 54. Well, see, 8, 9. So this is where you might get a calculator. 9 and 6, we already know. Oh, you know what? Yeah. 9 and negative 6. Those will work. Those multiplied to be negative 54 add up to be 3. So that means it'll become x plus 9, x minus 6 on the bottom there. And then this one here, same thing, but we need to be a negative 3 here. So that's going to change that to a plus and that to a minus. So this will be x minus 9, x plus 6. All right, that wasn't so bad. I'm just tired. Okay, same thing we did before in the previous problem. I'm going to get rid of this fraction. I'm going to multiply by the reciprocal. So I'm going to put x minus 9, x plus 6 here, and then over the x plus 9, x minus 6. So I took the fraction on the bottom and I flipped it and multiplied. And now I should get some good cancellation. This and this are gone. Let me see. Anything else? That's it. Unfortunately, that's the only thing. Okay, well, and that means that the final answer is just, let's see, these 3 multiplied on top. So I'm going to write that as x plus 6. There's 2x plus 6's being multiplied. So I'm going to put x plus 6 squared. And I have the x minus 9. And then over on the bottom, I have an x minus 6 and another x minus 6. So that's x minus 6 squared. Then I have the x. Oh, that wasn't x minus 9. I can cancel that. Man, I'm tired. Okay, so that's that for that. There we go. Okay. Subtract and simplify. So for this one, we need a common denominator. Unfortunately, we do not have a common denominator. So let me try and factor this. This becomes this one right here. This becomes x minus 6x plus 2. And then on this one, we need to multiply to be 48 and add up to be negative 48 and add up to be 2. So x plus 8, x minus 6. Okay, so when we look at this, we can basically rewrite this. Oops. X plus 8 over this thing. Trying to save myself some room. And this one, that over this factored. Okay, now to put these together, they have to have the same denominator. See, they both have an x minus 6, but the first fraction is missing the x plus 8. So I need to multiply an x plus 8 on the top and on the bottom. And then on the other one, this one on the right is missing the x plus 2. So I have to put an x plus 2 here, x plus 2 here. And now when I put that together, they both have the same denominator. So they both have x plus 8 times x minus 6 times x plus 2. And the numerators, I'm going to put those together, but first I'm going to multiply them out. So here, 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 here. If we FOIL that out, and I'm not going to show all the work here, we should get x squared plus 16x plus 64. Then I'm going to subtract from that whatever I get when I FOIL this out. So subtract, let me go ahead and take my time here. 4x squared, we should get plus 8x plus 9x, so plus 17x, and then the last multiplication would be plus 18. And then let me go ahead and subtract. So when I subtract, it's going to change the signs here. So it's going to change this minus 4. It's going to change that to a minus 17 and that to a minus 18. So now I just put all my like terms together on top. So x squared take away 4x squared is negative 3x squared. 16x and then take away 17x is minus x. And then 64 take away 18. Let's see, if we took away 20, it'd be 44. So 46. 46 right there. All of that over our common denominator, which would be x plus 8 times x minus 6 times x plus 2. All right, next one, we want to rationalize the denominator. So what we want to do here is rewrite it so it has no more square roots in the bottom. So what we do is we multiply the top and bottom by the conjugate of the bottom. So that is the conjugate. It's the same thing, but instead of the plus, we put a minus between the two terms. And now we just FOIL this out. And when we're done foiling, we should have no more roots in the bottom. So let me FOIL the top first. 1 times 5 is 5. 1 times negative 2 root 5 is minus 2 root 5. And then here to here, that's going to be minus 5 root 5. And then here to here, this is kind of tricky. A minus and a minus is plus. Let me do it up here. We're doing root 5 times 2 root 5. I already took care of the two negatives, and that became the plus. But when I do this, I can write this as 2 root 5 times root 5. And the root 5 times root 5 just gives us 5. So 2 times 5, that should just be 10. And then that's all over. Now when I FOIL out the bottom, I get 25. Now the middle terms are going to go away because this times this, that gives me negative 10 root 5. But when I go in the middle one, I get positive 10 root 5. So those are going to cancel. And then the last one is a tricky one again. You're doing, your answer going to be negative because one of them is positive, the other one's negative, but you're doing 2 root 5 times 2 root 5. The 2 and 2 multiplied to be 4, and the root 5 become 5. So 4 times 5 is 20. So we should have 20 there. And final thing here, top 5 and 10 is 15. Negative 2 root 5, take away 5 root 5 is minus 7 root 5. On the bottom, the middle terms go away, and 25 take away 20 is 5. So there we go, it's rationalized. All right, so now solving some equations. I think this is going to require a little bit more space. So let me just do these kind of one at a time here. So solving this equation, this is a radical equation or square root equation. So the first thing we do, isolate the root. It's already by itself. So all we have to do now is square both sides. Because we're squaring both sides, we will have to check our answers. Okay, so I square the left side and square root goes away. I square the right side, we get x squared. I'm going to move everything over to the right-hand side. So I'm going to be adding 5x to both sides and subtracting 24. And then now we have a nice quadratic. We can factor that to be x. Let's see, we need to multiply to be 24. So plus 8 minus 3. Set both of those equal to 0. We get two answers, negative 8 and positive 3. Now we have to check them. So when we check them into the original problem. So let me try negative 8. If I try and plug negative 8 in there, I'm going to get 24 minus 5 times negative 8. Does that equal x, which is negative 8? Well, I can already tell you this isn't going to work because this is 24 plus 40. There's no way that can equal a negative number, but what's that? 64. So root 64 is not equal to negative 8. It's actually equal to positive 8. So no go. That's not a solution. I have to check 3. So if I check 3 in there, square root of 24 minus 5 times 3, does that equal to x, which is 3? Well, this is root 24 minus 15 equals 3. 24 minus 15 is 9. Square root of 9 is 3. So 3 equals 3. That's correct. So the only solution we have here is 3. Okay, let me go to the next one here. Okay, another square root equation, but this time we have two roots. So what I'm going to do is I'm going to leave the root 7x plus 1 on the left. I'm going to move the other one to the other side, which makes it positive. Joins up with the 6. And now I'm going to square both sides. So I know I'm going to need to check my answer. So the left side just becomes 7x plus 1. That's nice. The right side sucks because we have to do square root of x minus 5 plus 6 times itself, square root of x minus 5 plus 6. So when I multiply here to here, I get the roots kill each other off. Here to here, I get plus 6 of those roots. Unfortunately, these don't cancel, the middle ones. You just get two, the same thing repeated. Then the last multiplication, you get 36. So we can do x, we can put the minus 5 and 36 together. That gives us plus 31. And then 6 of those roots plus another 6 is 12 of them. So that's our right-hand side, x plus 31 plus 12 roots of x minus 5. Now I'm going to move everything over, try and isolate this again, because I'm going to have to square both sides again. So I subtract x on both sides. I subtract 31, which gives me minus 30, and equals 12 root x minus 5. Here we go. Square it again. Oh, that's going to suck. Okay, so when we square the left-hand side, we actually have to FOIL that out. Now, squaring the right-hand side isn't that bad. You square the 12, that's 144. And when I square the square root, it goes away and just gives me the x minus 5. The important thing is that the 12 squared is going to multiply times that, so I have to have parentheses around that. Okay, left side FOIL, 36x squared minus 180x minus 180x again. That's all this multiplication. And the last one is plus 900 equals, I will distribute 144 through. So 144x minus, let's see. I don't want to mess this up. Let's see, 5 times 144 is 720, so minus 720. Okay, that's 36x squared. Let's see, I'm going to wind up bringing, well, this is, let's just do it, minus 360x plus 900 equals 144x minus 720. All right, let's bring everything over to one side. So I'm going to subtract 144x and add 720. It'll kill off the right side, we'll get 0 equals 36x squared. Okay, 360 take away 144, sorry, is minus 504 x and then plus 1620. Oh my goodness, that's ugly. I'm hoping 36 goes into all of those. I hope you can't hear my dog gagging in the background. Okay, 36, you can factor out a 36 from all of these. So you get x squared minus 14x and then plus 45 equals 0. We're getting there. Divide 36 on both sides and you still get 0 equals this. All right, now does that factor? Two numbers that multiply to be 45 add up to be negative 14. So x minus 9, x minus 5 should work. And so we have two potential solutions, 9 and 5. All right, we have to check those into the original problem, which is this right here. Put it right here. That's big. I wish it would not come in big like that all the time. Okay, let me try 9. If I try 9 in here, I get square root of, let's see, 7 times 9 is 63 plus 1 minus the square root of 9 minus 5. The question is, does that equal 6? So 63 and 1 is 64. Square root of 64 is 8. Minus 9 minus 5 is 4. Square root of 4 is 2. And hey, 8 minus 2 is 6. That works. So that is a solution. Let's check 5. I'll do it up here. So if I plug in 5 for x, we get 7 times 5, which is 35, plus 1 is 36. So root 36 minus, okay, square root of, let's see, 5 minus 5. That's going to be 0. Does that equal x, which is 5? That doesn't look right. Oh, sorry. Does it equal 6? Not 5. Sorry, 6. Does it equal 6? Well, yeah, this is 0 and square root of 36 is 6. So it works. So they're both solutions. All right. Next one. A lot of work here. Okay, so this, let's see, new page. All right, so this is a problem where it looks kind of like a quadratic. What we need to see is that we could rewrite this as 32x squared minus 4 times x squared minus 1 equals 0. And then we can make a substitution that u is equal to x squared. If we make that substitution, we can rewrite the problem as 3u squared minus 4u minus 1 equals 0. And that's a little bit more like a quadratic. So we try and factor it here. So let's see, I need something that multiplies to be 32, adds up to be -4, 32. Jeez, I'm sorry, my dog is bothering, or I should say my wife's dog is bothering me. Makes so much noise. How about we go with this? We go 8u, 4u, and then -1 plus 1. That should work. We get 32u squared minus 8u plus 4u. Oh, wait, we need to be minus. So yeah, minus 8u plus 4u is minus 4u, and then -1. That should be the factoring right there. So now we set each of those equal to 0. So 8u plus 1 equals 0. 4u minus 1 equals 0. So move the 1 to the other side, divide by 8. So -1/8. And same story over here. Move the 1 over and divide by 4. You get u is 1/4. Now, what is u? We have to switch back. So u is x squared. So we're saying x squared must be -1/8. And this one is saying x squared must be 1/4. Well, this can never have a solution because there's no number that we can square and get negative. This one, on the other hand, could happen. So now we take the square root on both sides, plus or minus anytime we take the square root, and the square root of 1/4. Well, that's just the square root of the top, which is 1, and the square root of the bottom, which is 2. So you get 2 solutions, plus or minus 1/2. And since we never squared both sides of the equation, we don't necessarily need to check these answers. Okay, number 10. 10 is very much like 9 in the sense that it's kind of looks like a square quadratic. It looks kind of like it. We have to see that this is 7, and x to the 1/3 squared. Because if we were to take this to a power, we multiply these two and we get 2/3. So that's just a fancy way of writing this. Then minus 48 x to the 3rd and minus 7 equals 0. So we're going to make a substitution. U is equal to x to the 1/3. And now I can rewrite this as 7u squared minus 48u minus 7 equals 0. And that we're going to try and factor because it's like a quadratic. It looks like we can go 7u here and u, and then 7 here and 1 here. Going to need to make this a minus and a plus. That way, when I multiply through, I get 7u squared minus 49u when I do the outside ones, then plus a u, and that gives me my minus 48. And then the 1 times -7 gives me -7. So that should be it. Set those both equal to 0. So u is -1/7, u is 7. And now replace u. So u is x to the 3rd equals -1/7. And then x to the 3rd equals 7. So now I need to get x by itself. So to get the x to the 1/3 to become x, I have to cube both sides. And when we cube, we do not need to check answers. So I cube the left side to get x. And then I need to do -1. I need to cube the -1, and I need to cube the 7. So when you cube -1, that's -1 times -1 times -1. That would still be -1. So we have -1 on top, and on the bottom we have 343. That's 7 times 7 times 7. And then on this one, we get x is equal to 7 cubed again, which is 343. So we get -1 over 343 and just 343. All right, let's talk about domains here. Let me take this whole problem. So the domain for this, you know what? Let me undo that. I'll do it a different way. Okay. It's going to be tight. There we go. One more. Okay, so for the first one, the domain of the original of the function f of x equals 4x squared plus x minus 1. The domain of f here is everything, all real numbers, because it's polynomial, right? It's a quadratic function. There's no division by 0. There's no square roots, so we can plug any number we want in here and we have no problems. On G, we do have a problem because we have a square root. We need to make sure that that underneath there is always not negative. So I need to make sure that x squared minus 4 is always not negative, means greater than or equal to 0. This is a quadratic inequality. So the proper way to solve this is to first turn it into an equation. Solve the equation. So I'm just going to move 4 to the other side. Take the square root on both sides, which would give me plus or minus 2. And now I will go to a number line. I will plot these 2 points. And then I will pick test points here, here, and here. And these will give me the regions where this is true. So let me pick a point to the left of -2, like -3. A point between -2 and 2, like 0. And a point to the right of 2, like 3. And what I'm going to do is plug these into this blue thing and see if it's true or false. So let's try -3 in there. If I take -3, we square it, and subtract 4, is that greater or equal to 0? So -3 squared is 9. 9, take away 4, yeah, and that's positive. So this region should work. If we try plugging 0 into that, we get 0 squared minus 4 greater than or equal to 0. Is that true? No, -4 is not greater than or equal to 0, so nothing here should work. And if we try and plug in 3, 3 squared minus 4, is that greater than or equal to 0? Well, yes, because that's 9 minus 4 greater than or equal to 0. That's true. So everything over here works. So we need to be greater than or equal to 0. We know we're equal to 0 at these points 2 and -2, so we want to include those. And then everything over here forever, everything over here forever. So if I do this in interval notation, it'll be everything from -infinity all the way up to -2, including -2, union everything from 2 on to infinity. That would be the domain. All right, the last one is kind of like the one we just did. We need to make sure that that stuff in the yellow is not negative, but it also can't be 0, because if that's in yellow as 0, I have division by 0. So that means I need strictly that 4 minus 3x is strictly greater than 0. Has to be positive, cannot be 0. And fortunately for us, this is a linear inequality. So all I'm going to have to do here is add 3x to both sides and then divide both sides by 3. And we get x has to be smaller than 4/3. So if this is 4/3 on a number line, we need to be to the left of that. And we do not want to include it, because if we include 4/3, we'll be equal to 0. We don't want that. So the interval notation of that domain is -infinity to 4/3 with a parenthesis on the 4/3. All right. Hold on, I need to pause this for a moment. Okay, next problem, difference quotient. All right. So these are really just algebraic problems, really kind of testing that you can plug things in and evaluate. So really the main part of this is just to figure out what this is. So what happens when you plug in x plus h into that function? Well, all the x's get replaced with x plus h's. Okay, so we're going to have to square the x plus h, which you do over here. Now, we've done that so many times, I'm going to trust you can get it. X squared plus 2xh plus h squared. That's what it would be after you FOIL and clean it up. Notice I kept the 2 out here in front and I put parentheses here. The 2 will have to distribute. Then this -3 can go through. And we still have the +1. Passing the 2 through, we get 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. That is just the top left corner of this expression. Now the good news is that f of x is just the original function. We'll just have to pay attention to that minus sign, and then we're going to divide the whole thing by h. So here we go. This difference quotient should be equal to everything we got in yellow minus the entire function f, all of it over h. Okay, this minus sign goes through and changes the signs of everything. So I'm going to go ahead and do that. This is a minus, this becomes a plus, and then this one becomes a minus, and I don't have that anymore. So now we get good cancellation. This and this are gone, this and this are gone, and then the ones are gone. So once everything is gone, notice that everything that remains on top has at least one h in it. So I'm going to factor an h out of the top, which will leave me with the 4x plus 2h. See, I still had an h there because there was an h squared. So, and then the last one, I pull that h away from the 3, and I just have 3. That's all over h, and we should get these h's to cancel, and that will give us our final expression, which is our answer. All right, that's that one. Okay, the next one, a little more complicated. It's got a fraction in there. All right, so again, most important thing is getting this. So that is f of x plus h. I replaced all the x's with x plus h. 2 and x plus h over x plus h, but then we still have plus 3. All right, that's not so bad. And then we have f of x, which is this original thing, and then all of that over h. Okay, let's write it out. 2 x plus h over x plus h plus 3. That's just the top left corner there. Minus, now I don't really need to do a parenthesis because I'm subtracting the fraction f of x, and all of that over h. Now, ultimately, we want that h to cancel. So what we do when we see something like this is we get a common denominator. So I need to multiply this first fraction by the other denominator, and multiply this fraction by the other one's denominator, x plus h plus 3. Top and bottom. Okay, now, when I do that, I'm going to have to multiply these together. That's going to kind of suck. So I'm going to put the 2 here, x plus 3. I'll multiply on the next line, x plus h. That's all that kind of rewritten. Then I'm going to subtract from that. This 2x will have to get distributed through this. And then that's all over the common denominator, which I'm not going to multiply out. That's x plus 3 times x plus h plus 3. But then all of that is still divided by h. What I'm hoping for is that when I multiply all that out on top, we're going to get something nice. So I'm going to do FOIL on this first, and I'll leave the 2 out there. So when I do that FOIL, I'm going to get x squared plus xh plus 3x plus 3h. Okay, that's this FOILed. I still have the 2 there. Here, there's no FOIL. I can just pass this through. So negative 2x times x is negative 2x squared. And then we have minus 2xh, and then minus 6x. All of this over the common denominator, which is x plus 3, times x plus h plus 3. And all of that over h. Oh my goodness. Okay, if I pass this 2 through, I don't want to rewrite this all. So imagine that I pass a 2 through to all of these. What would happen? That'd become a 2, that'd become a 2. This would become a 6. This would become a 6. So I pass that 2 through. And I'm really hoping for cancellation here. 2x squared minus 2x squared. 2xh minus 2xh. 6x, take away 6x. All I'm left with is a 6h up here. And that's really good because that h can cancel with that h on the bottom. Now, one way to see that is if you look at this as a fraction, you have a fraction over a fraction. So you could multiply this by the reciprocal of the bottom. So you could multiply this by times 1 over h out here. And then maybe it's easy to see that, you know, since all of this is gone, right, these h's would just go away. So what you're left with at the end of it all is a 6 on top, and then the common denominator on the bottom. X plus h plus 3, and we are done. Tricky. All right, next one. And last one for difference quotient. Okay. All right, so let's figure out what this is first. So what's f of x plus h? Well, that's f of x plus h is just rewrite this with x plus h in there for the x. All right, and then f of x is just that original function, then all divided by h. So let's do it. We're going to take the square root of x plus h plus 3, or minus 3. Subtract from it f of x, which is just the original square root of x minus 3, all of this over h. Now, to do this, you have to come in here with the conjugate. Now, we discussed this already. We come in here with the conjugate of this, which would have a plus between it. Multiply the top and bottom by the conjugate. And we do this because good things will happen when we do. Kind of like a trick. So when we multiply the top, the whole idea behind the conjugate is when we go here to here, the root goes away. And very important, when we do this times this and this times this, those red ones, those will cancel each other out. So we don't even need those. So the last multiplication is this times this. We'll have a negative times a positive, which gives us negative. And then since they're the same roots, the roots will go away. You'll be left with x minus 3, but that negative will have to go through. So that's why I put in parentheses. All of that over h times this denominator, which I'm not going to multiply. I'm just going to write it out. It's ugly, but I'm going to just write it. Because eventually what I want is this h to cancel. So let's see. If I distribute this negative through that parenthesis, turns out to a minus x, turns out to plus 3. And then I think we get the canceling we want. So all you're left with is an h on top, right? And that h, after everything else is kind of gone, that h and that h go away. You're left with a 1 on top. So your answer is 1 over that weird thing here. So square root of x plus h minus 3 plus square root of x minus 3. There you go. So conjugate here. Oops, what did I do? Nothing, I guess. All right, got the difference quotients. Is there another page to this? All right, is this the last part? Okay, great. Wonderful. All right, so is this even or odd? Well, if you reflect it over the y-axis, it lands on top of itself. So this is an even function. Find f of 1. So if I go to the x value of 1, what is the y value output? Well, it's 2. Okay, the next question says, for what x is f of x equal to 0? So we're trying to figure out where are our y values 0. Well, that happens here at -2 and +2. So x equals -2 and x equals +2. Okay, now it says find f of 3. That means plug 3 into the function, tell me what comes out. So if we plug in 1, 2, plug in 3, and then we look down here, up, we have an open circle. That means it's undefined there. Tricky, try to trick you. It's undefined, all right? You don't need an exclamation point. Okay, find the x and y intercepts as points. So I have 2 x-intercepts and 1 y-intercept. So the x-intercepts are the point -2, 0. The other x-intercept is 2, 0. And the y-intercept is 0, 1. What is the domain of this function? Well, it starts here at -3 and ends at +3, but it does not have points at the ends. So the domain should start at -3 with a parenthesis there and end at 3. The range is the y values, and you can see we start here -2, but we actually never hit -2 because they're open circles. We stop up here at 2. So it'll be from -2 to +2. We don't include -2, but we do include 2, so brackets on 2 for the top. All right, where is f increasing? So f is increasing everywhere we're in yellow. That's where we're going up as you move from left to right. And what we want are the x values where this happens. So it happens it increases between -3 and -1. I told you all in class, just always put it in the parenthesis on these, -3 to -1. And then also from 0 to 1. So union 0 to 1. Now it's decreasing on the blue parts. And that goes from -1 to 0. So it decreases from -1 to 0. Union, then from 1 to 3, even though we never reach 3. That's why it's actually kind of good to have it in parentheses. All right, find any local maximums, use a point for an answer. So I have 2 local maximums. These 2 are local maximums, highest points in that little area. So the point is -1, 2. So I'm going to write as a point -1, 2. And the other one is at 1, 2. Now for local minimums, I have this point here is the lowest point. These 2 endpoints are not local minimums because there's an open circle, so you can get closer and closer, but never actually get to -2. So I can't say it's a minimum. So I only have 1 minimum, and it happens at 0, 1. Now the absolute maximum value is the highest value this function ever gets to, which is 2. Okay, the highest value is 2. It actually reaches 2. Now, absolute minimum, there is no absolute minimum because -2, I actually never get to it, right? I get really close to -2 without actually getting there. And there's no way for me to actually say that. So I'm just going to say no absolute minimum. Okay, that is it. We are good to go. I hope that helps. I'm so tired. I hope I didn't make any mistakes. I'm sure if I did, I'll hear from you, but that'll be a good thing.